Hi, welcome back to my channel. Today we continue chapter 2 forces and motion 1 on topic 2.2 motion graph part 4. In this video I will discuss on problem solving involving linear motion graph. In order to solve problems involving a linear motion graph, you must understand all the properties of displacement time graph and velocity time graph. So in this video, I will discuss some of the examples and how to solve the problems involving a motion graph. Let's look at the first example 1. The velocity time graph in figure 2.30 shows the motion of Hasri. This determines his acceleration, displacement and average velocity. So for velocity time graph, you must know that the gradient of the graph is equals to acceleration and the area under the graph is equals to displacement. Okay, let's look at part A, acceleration. So in order to determine acceleration can be determined by gradient of the graph. So when you want to determine the gradient of the graph, we will discuss from these three sections. You can see there are different type of motion for these three sections. So from 0 to 3 seconds, you calculate the gradient, draw a triangle below the line, you calculate the gradient, thus acceleration equals to the gradient. So 6 minus 0 divided by 3 minus 0. So you get 2 meter second to the power negative 2. So you get the unit first before you write down the unit for this answer. From 3 to 6 seconds, this is constant velocity. So constant velocity, automatically you can write down acceleration equals to 0 meter second to the power negative 2. As you can see here, gradient equals to 0. Okay, and then for this part, you calculate the gradient for this part. This is negative gradient from 6 to 10 seconds. So acceleration equals to 0 minus 6 divided by 10 minus 6 equals to negative 1.5 meter second to the power negative 2. So if the question mention about determine acceleration for the whole motion, no mention about certain time interval, so you need to determine for all section, meaning from 0 to 3 seconds, then 3 to 6 seconds, then 6 to 10 seconds. Okay, next, B, displacement, same thing, you need to determine for all the section. Okay, so displacement S equals to area under the graph. So you want to determine for the whole motion, means area for the whole graph. Okay, so you can calculate by using a formula area of trapezium. If you don't know the formula, you can divide to 3 sections. So you have one triangle, one rectangle and one more triangle. So you just total up the area also can. So area of the trapezium is half times 3 plus 10 times 6. Okay, so you get 39 meter. Part C, average velocity. Formula for average velocity is total displacement divided by total time taken. So from here you can see end of the motion here is 10 seconds. That one will be the total time taken. And the total displacement is total area under the graph. So we have calculated here is 39 meter. So you take 39 meter divided by 10. So you have 3.9 meter second to the power negative 1. So this one is about problem solving involving velocity time graph. Okay, example 2, figure 2.31 shows the velocity time graph of linear motion of a car. Interpret the velocity time graph and sketch a graph of displacement against time, acceleration against time. This one need you to interpret and sketch. So same thing, you must know that gradient of this graph equals to acceleration and area under the graph equals to displacement. Okay, let's try to answer part A. We want to sketch a displacement against time graph. If you want to sketch displacement against time graph, meaning you need to determine displacement for each of the time interval here. From 0 to 10 seconds, 10 to 30 seconds, then 30 to 50 seconds. If you look at the type of motion, for 0 to 10 seconds, here is constant velocity or zero acceleration. 10 to 30 here, okay, uniform acceleration. 30 to 50 here, negative acceleration or acceleration in opposite direction, or we can say also deceleration. Okay, now we want to determine the first part, displacement. So from 0 to 10 seconds, you want to determine this displacement, meaning area under this line. Okay, so you just calculate area of this rectangle. So it's 10 times 10, so you get 100 meter. From 10 to 30, this is a trapezium. Okay, so half times 10 plus 16 times 20. Okay, so you get 260 meter. And then 30 to 50 is half times 16 times 20. So you get 160 meter. Okay, so you have all the values of displacement. Now we want to sketch a graph. This is a graph for displacement time graph. For the time taken here, you can just copy from here. Okay, the time interval should be the same. So from 0 to 10, we have calculated here, displacement is 100 meter. Meaning at 10 seconds, displacement is 100. And this one is uniform velocity. So the graph should be a straight line, positive gradient. Okay. From 10 to 30, 260 meter. Meaning at end of 30 meter, the total displacement is 100 plus 260. So it becomes 360, meaning at 30 seconds, total displacement is 360 meter. Okay. So the shape of the graph, this is acceleration, meaning velocity increases. For displacement time graph, gradient is velocity. So if gradient increases, the graph must be curved. For gradient increases, you have curve downwards. So you have this graph. Okay, the graph must be curved. Okay, and then for 30 to 50 here, 30 to 50, negative gradient or velocity decreases with time. So gradient increases will give a curved graph also, but a curved graph upwards. Okay, curve upwards, the graph. Okay, so you must be able to relate the type of motion to the shape of the graph for displacement time graph and velocity time graph in order to solve problem for part A. Okay, now look at part B. Same thing, we want to determine acceleration for all this section. 0 to 10 seconds, acceleration equals to gradient. As you can see here, gradient equals to 0. Thus, acceleration equals to 0 meter second to the power negative 2. From 10 to 30, this one is acceleration, uniform acceleration. So the gradient, you need to draw a triangle below this line. So it becomes 16 minus 10 divided by 30 minus 10. You get here. So you get 0.3 meter second to the power negative 2. Okay, the last part from 30 to 50, the gradient, you also can draw a triangle below the line. So the gradient become 0 minus 16 divided by 50 minus 30. It becomes negative. So negative 0.8 meter second negative 2. Okay, now we have all the values of acceleration. Now we want to sketch the graph. Okay, so this is the acceleration axis and this is the time axis. Now you can see the value of acceleration, there's a positive and negative value. So meaning for the y-axis, there must be positive side and also negative side. Okay, so for this part, 0 to 10 seconds, the value of acceleration is 0. So you must draw a line. Okay, if you use pencil, make it thicker, this part. So you can see there's a line. Okay, and then from 10 to 30, 0.3. So here you draw horizontal line, and then from 30 to 50 is negative. Okay, so 0.8 meter second negative 2. So you have this graph. So this broken line, you cannot draw full line. There is no line of graph here. This is only an interpolation line, just to show the value. So we draw broken line. Okay, no need to draw. If you don't want to draw, also can. But better to draw so that we can see all the value clearly. Okay, so that one is acceleration time graph. Okay, last part, formative practice 2.2. You can refer to your textbook. Number 1, how do you determine a velocity from a graph of displacement against time? Okay, as we know that for velocity can be determined by gradient of the graph. So velocity is determined by gradient of the graph of displacement against time. For B, acceleration from a graph of velocity against time. Acceleration is determined by gradient of the graph of velocity against time. Part C, displacement of a graph of velocity against time. Displacement is determined by area under the graph of velocity against time. Okay. Number 2, based on the figure 2.35, describe motion of the object from O to D. So you can see from O to D, there are a few sections here. 1, 2, 3, 4. 4 sections. So you need to describe for all sections. OA, AB, BC, and CD. So for velocity time graph, you must be able to identify a type of motion based on the shape of the graph. So you can see OA. What we can see about OA? OA here we have a constant gradient, thus constant acceleration. AB, constant velocity, gradient 0. BC, constant acceleration because velocity increases with time. And then CD, you can see velocity decrease. So you can see constant acceleration in opposite direction or deceleration. Okay. Number 3, figure 2.36 shows Rokia taking 3 minutes to walk to the sundry shop located 400 meters to the right of her house. After 1 minute, she buys an ice cream and walks to the playground located 300 meters from the sundry shop in 2 minutes. She sits and rests on the bench near the playground for 2 minutes. Then, using a shortcut to return to her house, Rokia reaches her house in 2 minutes. What is the average velocity of the motion of Rokia from house to sundry shop? So here you can refer to the diagram here. From house to sundry shop, the distance is or displacement is 400 meter. So you want to calculate the average velocity, meaning for part A1 is total displacement divided by total time taken. Okay, so you want to determine for this part only. So the total displacement 400, time taken is 3 minutes. You can see there are so many values here. So you can underline or write here somewhere so that you're not confused with the information given. So 400 meter, time taken 3 minutes. So 400 divided by 3 minutes convert to second. So you have 2.22 meter second to the power negative 1. And then part 2, a sundry shop to the playground here. Okay, playground, there's a bench there, meaning this one is a playground. Okay, so sundry shop to the bench is 300 meter. So 300 divided by time taken 2 minutes. Okay, so 2 times 60, so you get 2.5 meters second to the power negative 1. Part 3, playground to the house, meaning here bench, okay, to the house. So from bench to the house, you look at the path travel here, it form a right angle triangle. So meaning the shortcut line here, bench to the playground, the distance or displacement equals to 500 meters. So you can use a Pythagoras theorem to calculate. So the total distance travel equals to what? This one, part 3, you calculate. So V equals to S divided by T. Total displacement 500 divided by 2 minutes. Okay, so 4.17 meters second to the power negative 1. For part B, you want to calculate average speed. This is scalar. So total distance travel is the total length of path travel. So you just total up. No need to consider direction. So 400 plus 300 plus 500. So it becomes 1,200 meter. Total time taken, you need to total up all the time taken. 3 plus 1 plus 2 plus 2 plus 2. Okay, the total time taken. So we get is 10 minutes. So 10 minutes convert to second is 600 seconds. So average speed equals to total distance divided by total time taken. So 1,200 divided by 600. So you get 2 meters second to the power negative 1. Okay, number 4. A car is driven from rest and accelerated at 4 meters second negative 2 for 8 seconds along a straight road. The car is driven at constant velocity for 20 seconds, then brakes are applied. The car reduces its velocity at the rate of 2 meters second to the power negative 2 till it stops. Sketch a graph of acceleration against time, velocity against time, displacement against time. Okay, based on the information here, we can see there are 3 types of motion, meaning there are 3 time interval that we need to discuss. The first one is uniform acceleration. Second is constant velocity. Third is deceleration. Okay, so now we want to find all the values of acceleration, velocity, and displacement for all time interval mentioned here. Okay, now let's look at the first graph. So in order to draw the graph, we want to find all information about acceleration, velocity, and displacement. So I just make it in one table here. So we start with the first time interval, 0 to 8 seconds. So 0 to 8 seconds is a uniform acceleration. So we try to find displacement, velocity, and acceleration for the first time interval. So to find displacement for this part, so we use which formula? So we have 4 formula. You still remember linear motion equation. So you need to use this formula. Okay, so displacement S equals to ut plus half at squared. Because we don't have the value of v yet, so you can use this formula. Start from rest, meaning initial velocity 0. Okay, accelerated, so this is acceleration. 8 seconds, this is time. Okay, so you calculate, you get S equals to 1 to 8 meter. Okay, velocity for this time interval, initial velocity 0. So final velocity equals to u plus at, the first equation. Okay, so u equals to 0 plus 4 times t, 32 meter second negative 1. Okay, and then acceleration already given, so a equals to 4 meter second negative 2. Okay, now next for the second time interval, constant velocity for 20 seconds. For 20 seconds means after the first interval 8 seconds, add another 20. So here is the time interval 20 seconds. So 8 to 28 seconds. Constant velocity means acceleration 0. So we use the same formula, number 2. Okay, so S equals to ut plus half at squared, or you can just use the formula S equals to vt. Okay, so equals to 32 times 20. Where is 32? So this is the value of 32. At 8 seconds, the velocity achieved by the car is 32 meters second negative 2, meaning it will continue to move with that velocity. So that's why here V we use 32. Okay, so 32 times time taken 20, so we have 640 meters. Velocity we have calculated above here because uniform velocity, so V equals to 32 meters second negative 1. And acceleration you can write straight away 0 meters second negative 2. Okay, next The car reduces its velocity at the rate of 2 meters second negative 2 till it stops. The word stop here means the final velocity equals to 0. What is initial velocity? Initial velocity is 32 meters second negative 1. Okay, so at 28 second, we have calculated here the value is 32 meters second negative 1. So you calculate displacement. Which formula? We don't have time taken not mentioned here. So the equation that you can use is the number 4. Okay, so v squared equals u squared plus 2as. So here v equals to 0 because finally stop. U 32. A is negative 2 here given. You must put negative because this one is reduce. The velocity reduce means deceleration or negative acceleration. So must put negative sign. Okay, s. Then you calculate for s, you get to 56 meter. Okay, velocity, initial velocity is 32 meters second negative 1. So final velocity 0 meters second negative 1. Acceleration given negative 2 meters second negative 2. So based on this table, we have all the values of displacement, velocity and acceleration. So now we can sketch a graph. Okay, let's look at the first graph, acceleration against time. So by using the value that given earlier or calculated earlier, so we can sketch a graph. So let's get the first one. This is acceleration time graph. So you can there is a value of negative, so there must be positive and negative part for the A axis. Okay, so the time interval you can straight away mark. There are 3 time intervals: 0 to 8, 8 to 28, 28 to 44. Wait, where does we get that 44? This is coming from the 44 second. How we calculate this one is by using this formula. Okay, once you have all the formula U, V and A, then you can calculate T by using the first equation. Okay, using the first equation, we get T equals to 16 seconds, meaning decelerate in 16 seconds. So 28 plus 16, so we get here 44 seconds. This is the third time interval, 28 to 44 seconds. Okay, so we go back to the first graph. Okay, so you mark the time interval 0 to 8 seconds, 8 to 28 seconds, 28 to 44 seconds. Okay, now you refer to the table again. 0 to 8, the acceleration equals to 4. Okay, so you can draw a line. 8 to 28, 0 because constant velocity. 28 to 44, negative 2. So you get this graph for acceleration time graph. Okay, for the velocity time graph, okay, 0 to 8 just now is uniform acceleration. And then achieve final velocity 32 here. Okay, and then 8 to 28, uniform velocity 32 meters second negative 1. 28 to 44, decelerate or negative acceleration. So you have negative gradient, this part. Okay. For displacement time graph, 0 to 8 is uniform acceleration. So the graph must be curved for displacement against time graph. So this is the curve graph showing gradient increases or accelerate. 8 to 28, uniform velocity. So the graph will be straight line. Okay, because s against t, the gradient equals to velocity. 28 to 44, decelerate. Okay, so the gradient decrease. So the graph must be curved upwards. Okay, so we get this graph. So based on the information given, so you need to find all the information needed for the time interval mentioned, and then you can plot a graph. Okay, so for this part I will stop here. So that's all for the problem solving involving a motion graph. So you must do more exercise on this so that you get familiar with the question. Okay, that's all for this part. Bye.